Hello. Today we are going to look at the concept of theoretical yield, limiting reactant, and percent yield. Three of them combined in the same problems. Let's start with theoretical yield.
Antimony Sb and chlorine gas react to form antimony Roman numeral III chloride, SbCl3. This is represented by the chemical equation. The balanced reaction is. From stoichiometry, you should know that 2 moles Sb reacts with 3 moles Cl2 to produce 2 moles SbCl3. The same statement can be made in mass.
All right, remember that you can get your mass on your periodic table. The mass of antimony Sb is 121.8, and because you have 2 moles of that, multiply it by 2. That's what they did here.
Assuming the reaction goes to completion, and there is no loss anywhere, 456.6 grams of SbCl3 should be obtained. This is called the theoretical yield.
Now, the theoretical yield is more or less like what we call paper chemistry. That is what you do on the calculation. You work it out on your paper. Okay, this is what I'm supposed to get. All right. So when you get to the lab, when you do the experiments, whatever you get at that point is what we call the actual yield.
However, in laboratory, you are not given reactants in the exact ratio required to balance a chemical equation. For example, assume we are given 3 moles Sb and 3 moles Cl2. Then, with respect to the balanced chemical equation, only 2 moles Sb are required. Hence, 3 minus 2 equals 1 mole Sb is left over unreacted. This is called excess reactant. Note, Cl2 is completely consumed in the reaction. Here, Cl2 is the limiting reactant. Hence, in situations like this, a clear distinction must be made between excess reactant and the limiting reactant. The amount of product formed is determined by the amount of the limiting reactant. Limiting reactant and theoretical yield can be determined systematically by a stepwise approach. Example: consider the reaction. If 1.5 moles of Sb and 1.5 moles of Cl2 are given, determine the limiting reactant and calculate the theoretical yield in grams of SbCl3. Step 1. Calculate the amount of product formed if the first reactant is completely consumed. In order to do this, derive the mole ratio.
Remember, mole ratio equals moles desired divided by moles given.
Equals 2 moles SbCl3 divided by 2 moles Sb times 1.5 moles Sb equals 1.5 moles SbCl3.
All right, one thing I wanted to understand here is the conversion factor that we use here. Always remember to use your units. Units will guide you on what substance to be at the bottom, what substance to be at the top. All right, what you are looking for is always at the top. We are looking for antimony chloride from the question. But what you are given will be at the bottom. That is why you have the SB at the bottom. So once you have a mole of SB at the bottom, then mole of SB will be at the top. That is from what you have in the question, 1.5 mole of SB. So that the mole of SB will cancel out the mole of SB, and then you'll be left with the mole of SbCl3.
Step 2. Calculate the amount of product formed if the second reactant is completely consumed. Mole ratio is equal to moles desired divided by moles given is equal to 2 moles SbCl3 divided by 3 moles Cl2 times 1.5 moles Cl2.
Now, what we're doing here is you are producing the same products with the two reactants. Remember, you are given you are given 1.5 mole of SB, 1.5 mole of chlorine. So you are using these two reactants to produce SbCl3, which is you are using in grams. Remember, in our grams to grams, this is what we did. All right, so we're now applying our knowledge in grams to grams to the theoretical yield, limiting reactant, and percent yield this time around. All right.
Equals 1 mole SbCl3. Step 3. Choose the smaller of the two amounts. This is the theoretical yield.
All right, so once you use the two reactants to produce SbCl3, the one that has the lowest mole ratio is what you're going to produce. So that means because 1.0 mole of SbCl3 is produced, that is what you can get. You cannot produce 1.5 mole of SbCl3 because you already ran out of substance, which of course is chlorine this time around.
Mass is equal to mole times molar mass is equal to 1.0 times 228.2 is equal to 228.2 grams. The reactant that produces the smaller amount is the limiting reactant. Here, Cl2 is the limiting reactant. The theoretical yield is the maximum amount of product that can be obtained. It is assumed that all the limiting reactant is converted to product. In real-world, experimental errors could occur, resulting in less than the theoretical yield. The amount of product obtained by performing an experiment is called the experimental yield. Hence, percent yield is equal to experimental yield divided by theoretical yield times 100. Example: methanol, CH3OH, is produced by the following reaction. If 68.5 grams of CO is reacted with 8.60 grams of H2, calculate the theoretical yield. If 35.7 grams CH3OH is actually produced, calculate percent yield of CH3OH.
All right, this is the question we're going to walk through. We are given the balance equation. We are given the amount of CO, given the amount of H2, and if we are also given the actual yield of methanol. So we're going to calculate the theoretical yield before we can go on to use the formula for percent yield, since we already know the actual yield, which is 35.7 grams.
Convert 68.5 grams CO to moles. Molar mass of CO is equal to 28.0 grams per mole. Moles of CO equal 68.5 grams divided by 28.0 grams per mole is equal to 2.45 moles. Convert 8.60 grams H2 to moles. Molar mass of H2 is equal to 2.0 grams per mole. Moles of H2 equal 8.60 grams divided by 2.0 grams per mole is equal to 4.30 moles. Step 1. Calculate the amount of product formed if the first reactant is completely consumed.
All right, just like we did the first example, we are going to use the two reactants to produce the products. So we're going to look at which one is going to give us the smallest or smaller ratio and the answer.
Mole ratio is equal to moles desired divided by moles given is equal to 1 mole CH3OH divided by 2 moles H2 times 4.30 moles H2 is equal to 2.15 moles CH3OH. Step 2. Calculate the amount of product formed if the second reactant is completely consumed. Mole ratio is equal to moles desired divided by moles given equals 1 mole CH3OH divided by 1 mole CO times 2.45 moles CO is equal to 2.45 moles CH3OH. Step 3. Choose the smaller of the two amounts. 2.15 moles CH3OH is the theoretical yield, and H2 is the limiting reactant. Mass equals mole times molar mass equals 2.15 times 32.0 grams per mole equals 68.8 grams. Equals 52.0%.
All right, remember that 68.8 grams is your theoretical yield now, and 35.7 grams was given as the actual yield. So to get your percent yield, is actual yield over experimental, over theoretical yield times 100. That is what we have at the top. And that will give us the 2.0% yield. So let's do some interactive.
Example 1. Silver metal is heated with sulfur to form silver sulfide according to the following reaction. If 3.0 grams Ag and 3.0 grams S8 are given, determine the limiting reactant and calculate the theoretical yield in grams of Ag2S.
Okay, I'm going to pause the video. Make sure you complete this problem before you move forward. If 3.0 grams of silver and 3.0 gram of sulfur are given, determine the limiting reactant. So the same way we did the first two examples is that's what we're going to go through, apply to produce silver sulfide, Ag2S. So first of all, find out the theoretical yield, and then look for the limiting reactants, then get your theoretical yield for after you got your limiting reactant anyway. And then you can now go ahead and input the values in the formula.
Step 1. Calculate the amount of product formed if the first reactant is completely consumed. Convert 3.0 grams Ag to moles. 3.0 grams Ag is equal to
All right, when you convert 3 grams of silver to mole, what do you get? You look for your atomic mass of silver in your periodic table.
is equal to
Which is the mole desired of the products over the moles given. Remember, you are using the silver. That is the first reactant here. That's 8/16 times. Good. The mole, which is 0.0278. So the final answer here is 0.139. All right, so do the same thing for this one. Same step.
mass is equal to moles in times molar mass in grams per mole.
Right, the one with the smallest mole is 0.0139 mole of Ag2S from silver. That is what is used.
Is equal to
Number of moles, right there in the question. And the molar mass of Ag2S. That will give you. So what is the limiting reactant in this case?
Example 2. Consider the following reaction. Determine the limiting reactant when 2.50 grams of H2 are reacted with 2.50 grams O2. Step 1. Calculate the amount of product formed if the first reactant is completely consumed.
Okay, let me pause the video again for you to practice the question. Make sure you complete this practice question before you move forward.
Convert 2.50 grams H2 to moles. 2.50 grams H2 is equal to
I'll go ahead and input the answers. Mole desired from the balanced equation at the top and moles given. And multiply by your moles, hydrogen. And that gives you mole of water. The second reactant, which is oxygen, the same process, the same way. So the limiting reactant is
O2 is the limiting reactant. Example 3. Methane is combusted with oxygen to form water and carbon dioxide in the following equation. Calculate the theoretical yield for the combustion of 29.5 grams of CH4 with 115.0 grams of O2. Calculate the percent yield of CO2, assuming that 59.4 grams of CO2 are actually produced.
all right. I'm going to pause here. Make sure you complete this when you come to the class next day. Tomorrow, we're going to work this and we'll work in the group and show your answers. All right. Thank you for watching. We're going to stop here for this section of the stoichiometry. I hope you're able to take down some notes. See you in class tomorrow.